Okay, good morning. Thank you for joining us. We have about 20 or so people registered, so maybe some more people will be joining here a little bit later. We're going to record this session, so anybody that registered and is unable to attend or finds out about it after the fact, we'll have a recorded version to share with them. But we have a lot of information to cover today. It's going to be about a 90-minute webinar, so we're going to go ahead and get started. My name is John Ignosh. I work with Biological Systems Engineering, Virginia Tech and Extension. I'm based in Harrisonburg, Virginia. The title of today's webinar is An Introduction to RETScreen Expert. The agenda today is a brief introduction by myself, and then I'll hand it over to the RETScreen Expert trainer, Mr. Michael Ross of RER Energy. He'll start with some presentation slides and then go right into a software demonstration. While he's doing that, later in his presentation, I'll open up a few webinar survey questions. Just 4 or 5 kind of brief polling questions just to get some feedback from you all, from the participants. And a couple of notes on the webinar. The webinar is being recorded. I'm going to mute the participants' microphones just to minimize any background noise. Please ask any questions via chat box, and I'll show you where that is here momentarily. Later on, especially when we get into the software demonstration, if you can maximize the screen that will show the software that Michael's going to navigate through, you'll be able to a better view of what the screen looks like, buttons, that kind of a thing. So if you maximize your viewer window, that'd be helpful. This is an introductory webinar. We'll highlight many of the features of RETScreen Expert, but there's a whole lot to it, and we can't do it justice in 90 minutes. So we're not going to cover everything, but we will show where some of these features are, some of the functionality. We won't really be able to go into great detail on how to use these features. We'll show some in greater detail than others, but perhaps in the future, this type of material could be covered in greater detail in a in-person or longer training session rather than this introductory session. Thank you, everyone that registered to join us. We have participation from 4 countries. Michael's up in Canada, and we have participation from UAE, India, and then people scattered across the United States, including different locations in Virginia. Again, my name is John Ignosh. I work in Extension, tend to work on areas of farm energy efficiency, renewable energy conversion technologies, project assessment tools, and also some nutrient management technologies. This specific workshop or webinar is part of the Agricultural Energy Efficiency Initiative, a program for Southside and Southwest Virginia funded by the Virginia Tobacco Indemnification Revitalization Commission. I had a chat here, message saying that people cannot hear me. Can I get confirmation from that? If you can hear me, just put that in the chat box that you can hear me, or if your mic is not yet muted, go ahead and just let me know. Okay, I'm hearing some feedback that people can hear me. It looks like one user might be having an issue with the audio on their end. If you go into the audio controls, there should be a tutorial on adjusting your microphone. I guess not that you can hear, not that you can hear what I just told you, but when I'm done with my intro, I'll type a message to the chat box to that effect. All right, sorry about that. There's always some IT issues here. Again, this is this webinar, this educational webinar, is sponsored through a project, the Ag Energy Efficiency Initiative by the Virginia Tobacco Commission. There's a lot of different pieces to this project. We want to thank the sponsors for all their support. But basically, the general strategy is this energy action pyramid, and this specific pyramid is from North Carolina State University. But I think it's a great educational tool they put together. But essentially, the bottom of the pyramid is knowledge. Then you have conservation, efficiency, and then the tip of the pyramid is looking for appropriate applications of alternative energy systems. That's basically what our program tries to model by first raising awareness of how we use energy, understanding opportunities to conserve energy, looking for ways to use energy more efficiently, and then looking at appropriate application of renewables. Our primary clientele through this project, through this program, are farmers and forest product sector, or small businesses in the forest product sector. Part of this is to introduce people to energy-related decision support tools. These tools can be beneficial in exploring projects to screen out what isn't worth exploring in further detail, and also identify what might be worth taking a closer look at. It can help to also begin to partially fill this gap between what a vendor might be claiming are the merits of a specific project, perhaps with cherry-picked or overly optimistic assumptions, versus a robust third-party feasibility study, which in many cases for smaller projects may be more expensive or disproportionately costly compared to the project under consideration. And again, with these types of decision support tools and screening, you can go down that road of a third-party, a more robust third-party feasibility study with higher level of confidence because you've already done some degree of due diligence leveraging a decision support tool. And these can also be educational in helping clientele understand project components from a technical aspect, financial aspect, risk. Also, to that point, most clientele might not end up using the tool themselves, and depending on what kind of clientele we're talking about, from just based on our project experiences with this Ag Energy Efficiency Initiative, but the end user might not use the tool itself, or the client might not use the tool itself, but through their raised awareness of these types of decision support tools and project assessment techniques, they would seek the output from their service provider or vendor to help kind of compare different project alternatives. So again, kind of an educational aspect of these decision support tools and these types of webinars, just to let people know the different components in project assessment and the different criteria to evaluate different project alternatives. A variety of decision support tools exist within our Ag Energy Efficiency Initiative so far. We've primarily focused on RETScreen and also the USDA ARS Virtual Grower, which is a greenhouse energy management decision support tool, as the publicly available tools with supporting educational materials. So RETScreen has a variety of pieces, and Michael Ross will go into that in detail here. This is a 5-step standard analysis from the RETScreen 4 program, and the RETScreen Expert, I think, is somewhat similar in nature. The aspects to it that interest us initially were it was a freely available, validated decision support tool that a variety of renewable and energy efficiency projects could be evaluated within, and then also it was wrapped is wrapped in educational support, whether it's through sample case studies, templates, project documentation. Here's an example from the RETScreen Clean Energy Project Analysis Engineering and Cases textbook. You can see on the right side of the screen the variety of technologies that RETScreen deals with. And then the older version also included a website that had this type of information, excerpts to those guides, excerpts to case studies, voiceover slides, educational materials. So a variety of educational information is out there with regard to how to use RETScreen. As such, since 2012, we've worked with Michael Ross to have 7 educational events throughout Virginia focused on earlier versions of RETScreen, which were RETScreen 4 and RETScreen Plus. Late 2016, I believe, mid-2016 perhaps, RETScreen Expert, the newest version of the software, was released, and it has some different functionality to it, a different package. And that's why we thought this educational webinar today with Michael Ross would be a good thing to help introduce all of us to what is RETScreen Expert. So with that, back to the agenda. I'm going to go ahead and mute the microphones for the participants. If you can use the chat box, there's a screenshot of what the chat box looks like. It should be on the right-hand side of your screen, or if you've maximized your screen, the top of your screen with a kind of a pop-out menu for the chat. I'll monitor that during Michael's presentation and try to moderate questions and feed them to Michael Ross as he's navigating the software. With that, I'm going to introduce Mr. Michael Ross of RER Energy. Initially, we looked out there back in, I guess, 2011 for someone that was knowledgeable in RETScreen, and Michael Ross came highly recommended. We've completed 7 training sessions with him throughout Virginia, and he's done a phenomenal job. I think he's a great teacher. I think you're all in for a real treat today, and especially if we're able to figure out any future in-person sessions with him. He's a fantastic resource and a great teacher. A bit about his background. Mr. Ross has worked with renewable energy systems and clean energy technologies for over 20 years, has held research positions with CanMet Energy in the Advanced Energy Systems Group of the Department of Technical Physics and Mathematics at Alvar Aalto University, which is Finland's premier engineering university. RER Energy, Inc. is a consultancy focused on energy efficiency and renewable energy. Its main activity is research on system-level topics, including system optimization, component and system characterization, resource assessment, simulation modeling, and data analysis. With that, thank you all again for joining the webinar. I'm going to hand it over to Michael Ross, and he'll take it from there. Thank you all.
Thanks very much, John. I'll just get the screen sharing set up, and we will start the presentation, at least my part of it. So I'm now the presenter. Are you seeing my screen, John?
Let's see, not yet.
Okay.
Okay, looks like it's coming through.
Okay.
Perfect. I can see your first slide, and if you can maximize that, that'd be great.
Yep. Just working on that. Great. So thanks very much for attending this webinar. It's a great pleasure to be working with John again on providing some training on RETScreen. As John mentioned, this presentation is really an overview of some of RETScreen Expert's capabilities. So it's not intended to be a webinar where at the end of it you're going to know how to use RETScreen to do all the different things we're touching on. That would be too much to do in 90 minutes. So it's really just kind of an overview of what the software is capable of doing rather than a training session to teach you how to do it with the software. So for my part of it, I'm going to spend a short amount of time introducing the RETScreen software and then spend most of my time demonstrating with the software a number of different capabilities. So the first thing I'll look at as a demonstration is a feasibility study of a 10 kilowatt residential solar photovoltaic system located in Danville, Virginia. When we're done that, I will look at performance analysis, so tracking the ongoing performance of an existing system. And I'm going to do that for a small office building located in Burns Lake, British Columbia. It's a building for which I have some monitored data. And we're going to look at how energy efficiency measures that were done there impacted natural gas consumption. And finally, we're going to look at portfolio analysis very quickly, which is just a way of comparing energy consumption or production across multiple facilities. So if you're managing a large group of facilities, this is a way to look at the ensemble of facilities and get some understanding of where energy is being consumed, how it's being consumed, and what outliers there might be in consumption. So what is this RETScreen software? RETScreen software is a clean energy management software system for renewable energy and energy efficiency. It does both project feasibility analysis as well as ongoing energy performance analysis. It's been in development since 1998 by Natural Resources Canada, which is the government of Canada, part of the government of Canada. The most recent version, which as John mentioned came out last year, is RETScreen Expert. Now RETScreen Expert operates in one of two modes depending on whether or not you have a subscription. So if you have a subscription, it operates in professional mode. The subscription costs about $650 per year. So it's in Canadian dollars, but right now that's the conversion. That gives you the full capabilities of the software. If you're not interested in paying for a subscription, there is a free viewer mode. You can do all the analyses, however, you cannot save or produce reports. So that is a fairly serious limitation, but if you can work by that limitation, it is available for free. So what can this software do for you? Well, the first thing it can do is it can provide some benchmarking. So if you're interested in comparing your facility or your idea for a facility with similar facilities, and when I say facility, I mean that generally. So this could be a power project, like a photovoltaic power project, or it could be an energy efficiency project in a building. Anything that's consuming or producing energy, you can compare that with other similar facilities, hopefully located in an area near you. If you're interested in looking at the details of your system in a little bit more profoundly, then you can do a pre-feasibility or feasibility analysis. So here you're entering a description of your system and its location into the software, and it's providing with information that should allow you to decide whether this proposed project is technically and financially viable. So you've got this idea, you want to know, is this a good idea for a power project or an energy efficiency project? This will help you model the project and come up with an answer. The third aspect of the software is performance analysis. So you have built the project now, and you're trying to determine on an ongoing basis if it's performing in a way that meets your expectations. So you collect some monitored data from the operation of the system, and that could be something as simple as just collecting utility bills that come monthly, and you use that to assess whether the system is functioning as you would like it to. Finally, there's portfolio analysis here, which is comparing energy or fuel consumption or production across a collection of projects. So maybe you're managing 30 or 40 different projects, and you want to organize them in groups, and then within the groups see how different fuels are being used or how energy efficiency measures are being applied in those different buildings or facilities. Finally, RETScreen is useful as a platform for communicating project details because it's kind of a simple but more or less comprehensive way of encapsulating all the details associated with a project. And it also has a lot of built-in data and help. So even if you don't want to use its analysis capabilities, you may find just the data and help that's available through the software is useful for learning and useful for input into other tools. So what RETScreen is and what it isn't. RETScreen is not an engineering design tool. So if you think you're going to design a wind farm and lay out all the turbines in the optimal way using RETScreen, that's not the right tool. It's a pre-feasibility and feasibility assessment tool that does performance analysis and portfolio analysis, not an engineering design tool. It's not simulation software either. It operates using typical monthly or annual values. So there's some limitations associated with not being simulation software. By simulation, I mean software that operates by looking through the course of a year and every hour. I'm sorry, there's someone who's appears to be on another phone call, and their voice is coming through to the webinar. Could you perhaps mute your connection to the webinar? Thanks very much. So this is not simulation software. If it doesn't look hour by hour at what's going on throughout the course of the year, and as a consequence, it can't identify extreme events. So things like demand charges for peak consumption of electricity or gas cannot be dealt with in the software, at least identified within the software. Times of peak production or application of time of use tariffs is challenging with the software because it's not dealing with things on an hour-by-hour basis. For buildings, it's a fairly rudimentary model, so I tend to view it as energy accounting rather than true energy modeling. So you can set up an analysis of a building and its energy consumption fairly fast in RETScreen compared with other more advanced tools like eQuest or DOE2, but there's no way around the fact that buildings are complex and they have interesting energy behavior. So yeah, you can set up analysis quickly, but it's not going to do the same thing that a more advanced energy modeling tool is going to do. So what clean energy technologies can we deal with in RETScreen? Well, on a detailed level, there's PV, wind, and hydro plants, particularly run-of-river small hydro. You can also look at steam turbines, gas turbines, combined cycle gas turbines, solar air heating, solar water heating, or geothermal power. So those are dealt with on a fairly detailed level. There's a more rudimentary energy model available for the building envelope, building energy technologies, reciprocating engines, biomass combustion systems, and then some more exotic energy systems like tidal power, fuel cells, ocean current power, concentrating solar power, wave power. And if your project doesn't fit into any of those, you can kind of jam it into a catch-all other project, which doesn't allow you to enter a lot of energy modeling details, but allows you to at least use the financial and greenhouse gas emissions reductions analysis of the tool. Previous versions of RETScreen dealt with battery-based off-grid systems and combined heat and power systems. Those have not yet been implemented in RETScreen Expert, the most recent version. Particularly combined heat and power systems should be coming within the next year or so. If you're interested in those, you could go back to the previous version, which ran under XL and is called RETScreen 4. If you hunt around on the web, you may still be able to find a version of that, and it is free software. So the first demonstration I'd like to do is a feasibility study of a 10 kilowatt solar PV project. And we're going to imagine this project is located in Danville, Virginia. John tells me that the PV output might be able to earn, say, 10 cents a kilowatt hour if this farm had a net metering arrangement and was consuming a fair bit of electricity. We're going to assume the system price is about $2,800 US per kilowatt installed. That might be a bit high, but that's the number we're going to use. If you don't like this number, you can use the software and plug in your own number. And then I'm going to assume fairly low O&M costs, assuming that this isn't going to affect insurance costs too much, or that the land is already in the hands of the farmer, and so we don't have to have land costs. So O&M costs can be pretty low. So I'll assume $100 per year. So let's look at how the software would deal with that project. So this is how RETScreen looks. This is the opening page. You navigate through the software using these tabs up here, which change depending on the type of analysis you're doing. So I mentioned in my presentation that it does benchmark analysis, feasibility, performance analysis, and portfolio analysis. So we can access these different types of analyses by, for instance, opening one of these. So right now I'm interested in doing a feasibility analysis. So I click on this. It asks me if I want to save any changes. I don't have to worry about that. And it's going to configure these tabs across the top for a feasibility analysis. So now that's done that, there's a location tab, which we'll fill out shortly, and then there's a facility tab, an energy tab, a cost tab, an emissions tab, a finance tab, and then a risk and sensitivity analysis tab and a report tab. So we're going to go through these quite quickly just so you see what the software is capable of for this 10 kilowatt PV project. So here on the location page, the first thing is to specify where this is located. So I click here and it opens up a map if I have an internet connection. If I don't, you have other options. For instance, you can click over here on data, and it has a built-in database of climate data for different locations across the planet. But on the map side of things, I can specify that I'm interested in Danville, Virginia, and it finds that there are a couple of options there, so I click on one of them, and there I have Danville, Virginia. So it's placed two thumbtacks here. The one thumbtack indicates the location of my project, and it's placed that in downtown Danville. The other thumbtack is indicating where the nearest climate data location is. And there's this red dot here, which indicates that there is a ground station at the airport where they're measuring climate data. If I zoom out a bit, I'll see that there are stations available quite widely across Virginia and indeed the United States. So here, if we're looking at the eastern United States here, I can see that all these red dots are ground stations and all the blue dots are NASA stations. So that's where they wanted to kind of fill out the network of ground stations by using satellite measurements that are processed at the Langley Research Center of NASA, so also in Virginia, and that allows RETScreen to provide a worldwide climate data and weather data, even for locations where there aren't ground stations. So zooming in, back to where we were. If I move this thumbtack around, for instance, if I move it over here, it's going to move the climate data to the nearest station where I'm going to find climate data. But I'll move it back to somewhere around Danville. So this thumbtack I'm moving specifies the location of my project. This thumbtack is indicating where I'm getting climate data from. And if I want to move that from one station to the next, I can. So right now, I'm getting it from the airport, which is 7 kilometers away from where I placed that thumbtack. So once I'm happy with that, I click Paste Data, and it updates the image of that map right here, so I can kind of see what the situation of my project is. And if I look down below the map, I see the climate data that has been copied over from that database. So across the top, there's some identifying information like the latitude and longitude, both of the climate data location and the facility, and then some parameters that don't change over the course of the year. In this table, it shows me parameters that are changing over the course of the year, so January through December here, and then the values, the monthly average values for those parameters. So the average air temperature in Danville varies in this way over the course of the year. Now, of course, you're probably not interested in seeing that in degrees Celsius. I can change it to degrees Fahrenheit, as I can do that with all of these parameters. So unit switches are scattered throughout the tool, and generally speaking, you're going to have an opportunity to use U.S. customary units if that's your preference, although you will see a fair amount of metric units as well, because that is, the software is developed in Canada. So here's climate data for Danville. We don't need all of this for a solar project. In fact, the ones we're really interested in are this kilowatt hours of sunshine per square meter of area per day, which varies over the course of the year like this, and the air temperature here. But it brings in all this data so that I can use it for whatever type of analysis I'm doing, and other technologies may require different parameters. If I don't like these values, let's say I've taken a measurement on site and I find it to be different from these values, I can certainly overwrite these values. So if I thought that this was actually supposed to be 41 degrees Fahrenheit, I could do that. Along the bottom here, there's a graph that shows 2 parameters, up to 2 parameters from the climate database. So by default, it's showing in these bars. If I scroll down a bit here, it's showing the daily solar radiation on the horizontal. So that's these bars, and on the line, it's showing the air temperature. But if I wanted to change that to something else, like for instance the precipitation, for instance. It's very rainy in Virginia right now, John tells me, but there's the precipitation in the line. So it's just a way to visualize the monthly climate data using whatever 2 parameters I want to look at. So that's what you can do on this location page. You're mainly using it to specify where your project's located and then to get some climate locate data. Now, if you don't like the rest of the tool, just having access to climate data across the planet like this can be useful. So that's when I mentioned that there's a large repository of data and help. This is an example of some data that's available in the tool. Moving on to
a question.
Yes.
In the chat box here, is there a clear indication that historic values have been manually replaced? So if you made that edit like you did, does the software flag that by any way?
Well, what it shows is that before, like if I go, well, I won't reload this, but before this red ground measurement, where I'm indicating the source here, once I change that to 41, it changed this to user-defined, which indicates there's been a change in this column here.
Great, thank you.
Good question. Moving on to the facility page. Here on the facility page, mainly we're providing some information so that if we save this and then come back to it 6 months from now, or we share this with someone else, they'll know what this project is and who did the analysis. It also is a page where we see a benchmark. So looking down, we see there's a benchmark here, and I'll talk about that in a second. But I configure the benchmark by specifying across the top what type of facility this is. So by default, it's set to power. And if I look at power plant, I can choose between these different types of technologies that I mentioned on an earlier slide. By default, photovoltaics is chosen, so I'm happy with that. I can then enter a description like farm PV project, and I can enter, this is prepared for and if I wanted to enter more detail on that, I click over here on the right, and I can put in, addresses and emails and that sort of thing. I won't do that right now, obviously. And then I can also put my own name in here, and I could give the facility a name. Maybe if I knew the farmer's name where this was being installed, I could put that in there. Put in the address. The country is already being brought up from the climate page or the location page. There's an image over here. It's a generic image, but if I wanted to change that, I can select a different image. For instance, let's see. I have here, thought I had something saved there. Anyways, you can bring in a JPEG or a TIFF if you want to change that image. Across the bottom, we have the benchmark here. And this benchmark is going to look different depending on whether you're looking at a facility that's a building or whether you're looking at a power project. Here we're looking at power projects, so it's comparing your typical PV system energy production costs in US dollars per kilowatt hour with historical ranges for energy production cost on the central grid, and we can set a benchmark. So here in Virginia, assuming that we're getting 10 cents a kilowatt hour, setting the benchmark to 10 cents would be reasonable. And according to that, it looks like it's going to be challenging to make a profitable project because historic costs of energy production from PV are higher than that benchmark. Most of these are reasonable ranges. This isn't affecting your analysis anyway, it's just there for your information. However, if you don't like these ranges, you have a few options. And the one that I would say is out of date is the photovoltaic systems. Photovoltaic system costs, especially for big systems, are dropping 15% per year, and this is already out of date. So these ranges should extend down further for big systems. But if you don't like this and you just think it adds confusion, you can, for instance, get rid of it. So there I take the benchmark away, or you can adjust it as well. So if you thought that this was all too high, you could move everything down by, say, 10% by putting an adjustment factor here, and they all get shifted down. But in any case, this isn't affecting the rest of our analysis. It's just there for our understanding of how costs with different technologies change. Moving on to the energy page here, this is where we're going to actually enter the details of this 10 kilowatt photovoltaic system. So the first thing I need to do is specify what electricity and fuels are involved in the project. And just by default, there's always natural gas present. So this is a PV project. You might be asking yourself, what does natural gas have to do with the PV project? The answer is nothing. It's just here by default. But if you were doing a project that used natural gas, it'd be there for you to use. If you're using other fuels, there are a wide range of fuels you could add in, multiple fuels. So here's some conventional fuels you can see. Natural gas, it doesn't have to be in cubic meters. You can specify in hundreds of cubic feet or thousands of cubic feet or millions of BTUs or therms. You can deal with whatever unit you want for natural gas. Similarly, for oil and propane, you can deal with gallons. You don't have to deal with metric units. And if you want to look at some alternative fuels, there's a wide range of biofuels, like wood waste, for instance, that are in there. We won't be using those fuels. I just wanted to point out that they're available for you. What we will be using is the electricity export rate, which is just a way of saying what are we getting paid for every kilowatt hour of electricity generated. And the default value is 10 cents a kilowatt hour, which happens to correspond with the value that John suggested I use for Virginia. So now that I've got my fuels and electricity set up, I can add some technology here. So I'm going to add in a photovoltaic system, which I've just brought in there. I could have added in a wide range of other different technologies, but we're interested in a photovoltaic system, so I'll limit it at that. Here's an example of a rudimentary level model. So when I said that some technologies are dealt with only in a rudimentary way, we have an example for the PV system. So if I wanted to deal with this in a very rudimentary way, I'd say, look, it's a 10 kilowatt PV system, and its capacity factor is, say, 20%. So just to review, a capacity factor is a measure of the average output of a power system expressed as a percentage of its nameplate capacity. So for this PV system, the nameplate capacity is 10 kilowatts. However, it doesn't always put out 10 kilowatts. At night, it puts out nothing. During winter, probably it's putting out less than 10 kilowatts most of the days too. During summer, maybe for a few hours per day, it's putting out close to 10 kilowatts. But if we average that over the entire year, maybe we'd find that on average, this 10 kilowatt system is putting out 2 kilowatts. So then we'd say the capacity factor is 2 over 10 or 20%. So as a rudimentary model, I could say there's a 10 kilowatt system with a capacity factor of 20%, and there, that's an analysis. However, that's not really that useful if you don't know what to put in for the capacity factor. And we would like the software to tell us what a reasonable choice is. So to help us with that, we can do a more detailed model. And this exists for the technologies that I said have more detailed models. So I go to level 2 here, and it allows me to specify the orientation of my panels, the losses related to different things like the temperature and the inverter efficiency, and then it'll calculate the capacity factor for me. So assuming that this is on a ground-mounted tracker, let's assume that it's fixed and it's maybe at a slope of, say, 20 degrees, and it's facing due south, I would enter something like that. Now you might say, well, wait a second, what's this azimuth, and how did you know that I had to enter 0 for that? Fortunately, there's pretty good help in RETScreen. So when I position my arrow cursor over azimuth and I click on that, it opens up this help that tells me in words what the azimuth is, and also has a pretty useful diagram here that shows that if I want my system to face due south, I would enter a value of 0. So it's giving me the convention that's used in RETScreen. So that's why I entered 0 here. I'm assuming it's a south-facing, tilted at 20 degrees. And if I want to see what impact that has on the solar radiation, I see here's the tilted, or rather here's the horizontal value, and that's coming directly from the climate data. But here's the value once the array's been tilted up by 20 degrees. So we see we get a little bit more by tilting it up. Yeah, so having specified the orientation, we move on and we specify the DC side of things. So PV system will have photovoltaic modules or panels that put out DC direct current, and then it'll have a box that converts that direct current into alternating current that can feed onto the grid. And that box is called an inverter. It's a box of power electronics. So let's first specify the DC side, the photovoltaic array, and then afterwards the AC side, the inverter. So I can choose what type of module technology I want. About 90% of the market is silicon, so poly or monocrystalline silicon. So I'm going to choose polysilicon. Over here, there's a little shopping bag icon, which indicates that if I click here, it opens a product database. And if I look here, I can see there's a wide range of manufacturers here, not all of which are still, selling modules. So it's not a complete database. But if I pick, for instance, Rene Solar here, I can see a selection of their modules. So here's a 250-watt module. If I put on 40 of those, I'd have a 10 kilowatt system. So I could click OK, and then that gets filled in there. Now, if I didn't find my module that I wanted to use in there, that's not a problem. I just specify the power capacity here and the efficiency for my module here, and everything else is fine. Here I have to specify the miscellaneous losses. So this reflects that PV modules get dirty, sometimes snow gets on them. They're not all perfectly matched. There's wires that connect them to the inverter that have, a small amount of voltage drop, etc. So there's all these things that lead to losses. We're going to encapsulate all that into a single number. To get an idea of what a reasonable choice of number would be, I can, click on the help here, and it says, typical values range from a few percent to 15%. So I'm going to say, let's assume this is around 10%, which at a very quick, feasibility level or pre-feasibility level analysis would, be a reasonable starting choice for that value. For the inverter, a 10 kilowatt inverter should be relatively efficient, so maybe I put in 97% efficiency here. I'm going to assume the inverter is sized to meet the modules. You could also put in a different size inverter. Here's miscellaneous losses again, but this time it's on the AC side. And if I look at help for this, it says in most cases this value will be 0. And I think for a residential PV system, that would probably be a reasonable starting point for that as well. And based on that, it's calculated a capacity factor for me. So 15.3%. On average, over the course of the entire year, this 10 kilowatt PV system is putting out 1.5 kilowatts. And that's a capacity factor that's based on this DC capacity here, 10 kilowatts. So if I change the AC capacity, it won't change. Now, John told me that it's going to be around $3,000 per kilowatt. I suggested that we put in 2,800. There is over here an icon that gives us to the cost database. Unfortunately, for photovoltaic systems, once again, these numbers are already a bit out of date. So I don't think it's too bad for small systems, but for big systems, the costs are high here. But looking at a 10 kilowatt system, its suggestion is $26.40 US dollars per kilowatt. I'm going to put in the 2,800, but if I wanted to use the database, I could have just copied that value over like that. If I want to specify that I'm counting on $100 per year for O&M, I could just put in the O&M. Once again, there is this database to help us. And so there, it's telling me that I'm exporting 13.4 megawatt hours per year to the grid at 10 cents a kilowatt hour. That's $1,340 per year in revenues just from the energy generation here. So that's the energy page. After that, all these other pages essentially are the same regardless of the technology. So the values may change, but the look of the page is the same. So if I go to the cost page, for instance, it always looks this way. I have, 3 choices of the level of detail I want to enter. In the most basic level, it just copies over the costs that I entered on the energy page. So these 2,800 and this 100 here got copied over, 28,000 and 100 here got copied over. And if I wanted to add in any additional costs that I thought were appropriate or savings, I could do that here. Now, if I want to specify things in more detail, I can pick a level 2 or a level 3 analysis even, in which case I have lots of space to put in different details associated with the project. And in this case, I'm not limited to just the initial costs, like the $28,000 I pay to buy and install the system, and the annual costs associated with operation and maintenance. I can also put in periodic costs. So these are things that might be occurring every 5, 10, or 15 years. So in the case of a PV system, I might, for instance, put in inverter replacement here and say, after 13 years, maybe put in $1,000 for inverter replacement. Now, I'm not going to do that for this. I'm going to go right back to level 1 here, but I just wanted to show you that's another functionality of that.
And Michael, there's a question on the chat here regarding, have these values been produced by PV watts or compared to PV watts, and if so, are they roughly equivalent?
Yeah, very similar. Where there's a difference is PV watts, for instance, breaks out the miscellaneous losses, and here you're just kind of putting in a value. And in a way, that allows you to exactly match the PV watts output just simply by changing your miscellaneous losses to match that. But typically, the results, if you're keeping your miscellaneous losses around 10%, are going to be very similar to PV watts. Yeah.
Thank you.
So the next page is the emissions. Some of you may be interested in the impacts on the greenhouse gas emissions associated with your project. So typically what we're doing, for instance, for a grid-tied PV project is saying, well, if we didn't do this PV project, this electricity would be generated with a bunch of sources on the grid, and that would lead to certain emissions in the base case. However, we're proposing to generate this electricity with a PV system, and that's going to have hopefully a lower amount of emissions. So we're actually reducing the emissions associated with this amount of electricity production. And the difference between what would have occurred if we didn't do the PV project, so in the base case, and the proposed case is the emissions reductions. And if you're interested in that, that can be calculated. So there's a number of different ways to do this. The default way that's used in RETScreen is to say, well, the average emissions for Virginia from a certain database, which may be out of date now, is about 470 kilograms of CO2, or 0.47 tons of CO2 per megawatt hour of generation. And we can add in some transmission and distribution losses, and we end up with half a ton per megawatt hour here. However, if we wanted to use a particular mix of fuels to generate our own figure, we could say, well, let's say that Virginia's production of electricity is going to be a mix of natural gas and coal and hydro. And I don't know what the correct numbers are for this, but let's say I put in 25 and 25, so a mix of fuels here. Then I can calculate my own emissions factor, which just by chance happened to work out to pretty much exactly the same number we were just dealing with. But that shows you how you can specify what your emissions are in the base case. It knows that for a PV system in the proposed case, the emissions are 0. If we put the T&D losses here to 0, we can see that in the base case, generating this 13.4 megawatt hours would result in 6.8 tons of CO2 emissions, or CO2 equivalent. In the proposed case, there are no emissions, at least associated with the production of the electricity, so the difference is 6.8 tons. And is that a lot or little? There's an equivalence calculator here to help you understand, in more visually easy to interpret terms. So it's about 16 barrels of crude oil that aren't being consumed, just as an example. And if you want to do a project where you can actually get some monetary benefit from the greenhouse gas emissions reductions, you can put in a value here. Like if you thought you could get $10 per ton, you could say, well, I can get that over, say, the 20-year life of the project. And then you could specify an escalation rate and a transaction fee, and it would include that in your financial analysis. But here, I'm going to assume that's not the case. A small system like this, it'd be hard to tell the emissions reductions directly. On the finance page, we can bring this all together. I'm going to switch right to a little bit of a more detailed analysis here. So I'll go to level 2. We can specify the inflation rate, which is being applied to, the O&M costs, the discount rate, which essentially we can say is what's the target for profitability. So if this farmer said that, he wanted to earn, or she wanted to earn, a 10% return, internal rate of return on their equity portion, so the amount that they're putting in, then that would be essentially the discount rate is 10%. We specify the project life. A PV system should last about 25 years, so I put that in. And then we can specify, maybe 50% of this is being financed out of debt, and maybe the interest rate is, say, 5%, and that's being paid back over 15 years. So based on that, here is the cash flows for the project. So here's the cash flows year by year. This is the initial equity portion. So we're doing 50% debt financing. So we have a project that has total initial cost of $28,000, but we're only paying for $14,000 of that out of our pocket. The other $14,000 is coming from a bank that we pay back over time. So that's why we see $14,000 here. And then it turns out that our revenues of about $1,300 per year line up almost exactly with our debt payments. So we're earning $1,300 per year in revenues from the sale of electricity, but we're paying $1,300 for our debt. So that's why we don't see anything really interesting or positive occurring until 15 years out. We see that here. Nothing really changing, and then 15 years out, the cumulative cash flow graph starts going positive. So here's the annual cash flows, here's the cumulative cash flows. And as a result, the project is not very financially attractive. So it's got a low internal rate of return, 2% negative net present value, because this internal rate of return is below that 10% that the farmer has said they want to achieve. So yeah, not terribly attractive. However, we could say that there is essentially this tax credit, investment tax credit, that's roughly 30% the cost of the system. So if I put in, let's see, $8,400 as a tax credit here, and then maybe I adjusted the debt to reflect that we still want to be putting in more or less the same amount of money as our equity portion, but we're getting $8,400 back from the investment tax credit. Maybe I would drop this down, say, to 25%, so that we're still putting in an equity of roughly $14,000 when I take into account the tax credit. But now our debt is reduced, so you see that the debt payments are less each year. So the revenues exceed the debt payments, and we have an upward sloping project like that. It's still not fully profitable. We could see if RECs make a difference, so renewable energy certificates. So if I look at clean energy production income, if I thought that I could get, say, I don't know, $40 per megawatt hour, I don't know if this is realistic or not, but if I thought I could do that, there I see now I'm at the 10% internal rate of return. I still have a fairly long payback period, but I have achieved the 10% internal rate of return, so it is now technically a profitable project according to this target that we've set. So that's showing you how you can adjust financing parameters and assess the profitability of the project. Of course, we've made a lot of guesses about what we're doing here, so we might want to check some of those guesses by looking at sensitivity and risk analysis. Now, one way to do a sensitivity analysis is simply to change your numbers in these different pages to see what impact that has. And I actually prefer doing that because I find it helps me understand better what's going on in my project. However, if you like to do that in a kind of a more systematic way, you can go to this risk and sensitivity analysis page, and across the top we have a sensitivity analysis, and across the bottom we have a risk analysis. So the sensitivity analysis allows us to vary two parameters simultaneously and see what impact that has on some metric of profitability or quickness of return. So if we're looking at the pre-tax internal rate of return on equity, so a measure of profitability, and we wanted to vary two parameters by plus or minus 20%, and we said that we wanted to achieve a 10% IRR in order for this project to be profitable, we can see that here the initial costs are varying by plus or minus 10% and plus or minus 20%, and here the electricity export rate, so what we're getting paid for the electricity, is varying by plus or minus 10 and 20%. The white combinations are combinations where we've exceeded this 10% target for profitability. So those are profitable projects, so profitable combinations. And the red or orange cells indicate we have not achieved that 10% target, so those are not profitable projects. And when I look at this, I see, well, it looks to me like initial costs are actually more important than the export rate, because, for instance, if my initial costs go down by 10%, doesn't matter what happens with my electricity export rate, I have a profitable project. However, if my electricity export rate goes down by 10%, I can still have an unprofitable project. Rather goes up by 10%, I can still have a project that isn't profitable if my initial costs have gone up. So when I look at this, I see initial costs are more important than the electricity export rate. I can choose which parameters I'm comparing, and I can compare multiple sets of parameters. So scrolling down here, here is the comparison against operation and maintenance costs, which have very little impact. Here we're comparing debt, interest, and debt ratio, but I can also choose to compare initial cost with, say, the clean energy production rate. If it's not 4 cents per kilowatt hour, but less or more, this is the impact that's going to have. So I can choose what parameters I'm comparing from those lists and do a sensitivity analysis that way. That's for, yes, go ahead.
All right, there's a question here in the chat box regarding where you entered the escalation rate for the electricity prices.
Mm-hmm. Yeah. Here, right down here, that's the electricity export escalation rate. So I'm saying that's escalating 2% per year. And I also have inflation set at 2%. So this is being applied to O&M, and this one is being applied to electricity export rate. And for the clean energy production revenue, I left this blank. So let's see, I should put in a number of years here and say no escalation on that. That's another escalation rate there. So particularly if you've chosen level 2 here, you can specify different escalation rates for different future costs and revenues.
Great, thank you.
Now here I was looking at sensitivity analysis, which is for simultaneous variation of 2 parameters. If I keep scrolling down, I get to risk analysis. So if I want to do that same type of thing for the pre-tax IRR and equity, I could say, well, I really don't know exactly what my initial costs or my O&M costs are going to be or how much electricity I'm going to export to the grid. Let me vary that over a range of plus or minus 20%, 25% around this central value that I've specified earlier in analysis. So I specified $2,800 as the initial cost. Maybe it's plus or minus 25% or some value in between. And what RETScreen does is recalculates the analysis, the value of the pre-tax IRR and equity for 500 sets of randomly chosen variables within these ranges. And then using that, it can prepare a distribution of potential outputs. So if I wanted to see the entire distribution, it looks like that here. And I see, yeah, most of the time I'm right around 10% internal rate of return. There's a small probability I'll have quite a bit higher internal rate of return, and also small probability I'll be down around 4%. But here I can get an idea of the range of possible outcomes and the probability of those outcomes, assuming that the variation in my inputs is described by this range. And of course I can change these ranges, right? If I thought the initial cost could actually be plus or minus 30%, I can change that. And then things get recalculated. We get a slightly different distribution. So that's the risk and sensitivity page. When we're happy with everything we've got, we go to the report. We can create a report, generate a PDF. It'll reflect what we have. So if I had changed the image, it would show that there. You see what I entered for the prepared for and prepared by there. And if I want to put out the values of the worksheets themselves, I can also export that as a PDF. Let's see if I put that to the desktop. Do that. Save that, and then go back to the desktop here. I should see somewhere if I can find it. Nope. Yeah, here it is. So just open that up to show you there's a PDF been generated of the worksheets that I prepared for you here. And that's customizable, right? You can go through each page and do things like adding annotations or changing what appears on the page to make your report as you would like it to be. So I mentioned that there's a benchmark here. The benchmark changes, and that's really all I wanted to say about the solar PV system, because we don't have much time, so I need to move on to other things here. I mentioned that, yeah, go ahead, John.
Two quick questions. One with regard to the benchmark feature. Is there any tool within the benchmark for anaerobic digestion projects? There's a question from the chat box, or how that would be incorporated into the information in the benchmark there.
Okay. What was the second question, just so in case I can get them both at once?
The number of languages that RETScreen comes in is the second question on the chat.
Okay, well that's an easy one. You can convert languages by choosing from this list. So there are the languages that are available. So for instance, if I wanted to share this project with partners that were from Korea, and I wanted to make it easy for them to understand what I've done, I could pick here on Korean, and it's not going to translate what I've entered, but it's certainly going to translate all the parameters here. So there's your Korean version. Everything, even across the top, is in Korean. So I hope I can find my way out of this. So yeah, those are the languages. I think it's 36 different languages. The second question is on the benchmark. I don't know right off the top whether we have whether they have anaerobic digester in there, but what I can do is I can show you how I can change the benchmark by going, for instance, to agricultural here. Instead of a power plant, looking at an agricultural plant. Let's see, and what do we have here? This is getting very slow all of a sudden. This is worrying me. Yeah, there we go. So we don't have anaerobic there, but what we might have, yeah, I'm guessing we don't have, but just so you know what is available, when I change this benchmark looks quite different now because it's for a building, and there's a benchmark given here in kilowatt hours per square meter. Now you probably want to see that in per square foot. For a greenhouse, for instance, this is some sort of benchmark. Where that benchmark comes from is this benchmark database. So if you're interested in what benchmarks are available, here's the benchmark database. And if I reset this all, you can see that you can configure what benchmarks you're looking at based on these different categories. So if I was only interested in, say, benchmarks for the United States, I would go down this list and I would click United States here, and then these are the benchmarks that are available for the United States. If I'm only interested in, say, industrial applications here, there is an agricultural in that list. I'd find that, but there I can see that there's, beverage, tobacco, food, grain and oil seed mill. So there are some agricultural benchmarks, wood, forestry benchmarks built into the industrial benchmarks here. So I can filter through these benchmarks by choosing different choices across the top. If I only wanted to, say, look at, I don't know, this is always dangerous, but if I wanted to look at, I don't know, pulp and paper, paper mills, those are the benchmarks that are available there, at least for the United States. So that's where these benchmarks are coming from. It's this database, and you can maneuver through this database looking here with this. So I don't think there is, for anaerobic digestion, there's a benchmark there. But if you have your own benchmark, you could perhaps enter it in facility somehow to get it to reflect that.
And Michael, I don't know if I recall this correctly or not, but it seemed like the RETScreen 4 perhaps had a case study. I don't know if it was a combined heat and power case study that featured an on-farm anaerobic digestion system.
Yeah, it had actually 2 case studies in there. Unfortunately, as I mentioned, combined heat and power is a functionality that existed in RETScreen 4, but they haven't yet added back into RETScreen Expert, and it should be appearing in the next year.
Great,
but I don't think you're going to find that here. But let's take a look. So case studies, as John mentioned, are built-in projects that have been fully worked out that you can look at to better understand either how the technology works or how RETScreen can be used to model the technology. So if I go to open here and I look at case studies or templates, I have about 100 different case studies and templates here related to projects that I could look at. So if I, let's see what I look at. I look at power plants. There are the power plants that are there. I don't see an anaerobic digestion currently. Probably within a year, as I mentioned, they're going to have the combined heat and power built back in, and there you're going to see a farm case study where they're using anaerobic digestion with a dairy farm to provide heat and power for the farm. So each of these is like a worked out case study that you can click here to read. Well, that's not very interesting. Some of them are more interesting than others. If you look, let's see, power plant. If I look at wind turbines here, yeah, I'll just try some. Like I said, some of these are more interesting than others. For India here, yeah, here's a 20 megawatt Indian case study. There's a description. It's written like an assignment. So if you actually want to test yourself, you could try and figure out on your own how to do this. There's a description of the real project that this was based on. And if you clicked on this, you would actually open the project and the worked out analysis will appear there. But I'm going to not do that just because I want to keep this around in case anyone has any questions. So the last thing that you might be interested on the feasibility side of things is this virtual energy analyzer. So we started our project by going to this homepage and saying, just open a feasibility analysis. And that opened up a blank feasibility analysis. But if I wanted to have my feasibility analysis populated with some default values that were more or less appropriate for the project, I could have picked the virtual energy analyzer. So here I could have clicked on this and said, it's actually a power plant and it's a photovoltaic project, and I'm going to locate it here in Danville, so I won't change that. And then I click OK here. I'm not going to save the changes. Just going to do this. What it's going to do is, rather than opening up a blank analysis like we did before, it's going to open up an analysis that's populated with values. So if I now, for instance, go back to the energy page here, here's a photovoltaic, 10 kilowatt photovoltaic system already filled out for me. Now, these values may not be exactly right for you, but they are some more or less reasonable default values that you can get started with for doing your analysis. So that's an example of an archetype for a power project. Archetypes are also really interested. They're called archetypes, I should say. They're the kind of set of default values that the virtual energy analyzer uses to populate a new feasibility analysis. These archetypes are pretty useful when you're dealing with energy efficiency projects. So for instance, if I was interested in an agricultural project and I wanted to look at a greenhouse, I could pick greenhouse here. I'll just leave it in Danville again. And then, do I want to save changes? No, I don't. And it's going to kind of build the model of a greenhouse in RETScreen, so I can look at how this greenhouse would look. Now, it doesn't change the construction of the greenhouse or the poultry barn or the office building depending on where you've located it. So it's, done that analysis actually for Ontario, and then it's kind of moving that building to Virginia. And that has certain dangers associated with it because, for instance, a poultry barn in Ontario is built differently than a poultry barn in Virginia because the climate is different. So there are some dangers, but at least it gives you some ideas about how you can model your, for instance, your greenhouse. So here's an example of a greenhouse in there. There's a building envelope to put in here. So if I look at the building envelope, it's provided some information about the orientation of the buildings and the wall area and what type of windows have been used in there, how much they're shaded, what the roof is, what skylights are there, the floor, any natural infiltration of air. And I could also put in a ventilation system. It doesn't appear that there's a ventilation system in this presently. But, pumps, motors, lighting system are all put in there. So you can kind of build out a simple model of your facility and then look at changing things from the base case to the proposed case and see what impact that has on energy efficiency. So here I just clicked on Include Measure here, and it generates this table which shows me in both the base case and the proposed case what the impact of different measures are. So if I'm interested, for instance, in the fuel consumption in the base case, I click on that, and it shows you, that the building envelope is consuming that for heating, the lights are consuming that for electricity. There is no cooling here. This is the motor electricity consumption. If I want to compare that with the proposed case, I do that. I see there's been some significant changes, and I can look at the savings by doing this. And down this side, I can see, how much the proposed case changes would cost and what fuel savings they result in, if there are any incremental O&M savings, and then what the simple payback for the measure would be. And I can choose whether to include that measure or not. So that's kind of how you can build out a facility analysis that's particularly useful for energy efficiency. Any questions or comments on that before I move on to performance analysis?
Nothing in the chat box right now on that.
Okay. So let's move on then to performance analysis. And the idea here is we're no longer looking at something that we're thinking about building. We've already done something, and we want to make sure that it's performing as we think it should. So I have some gas bills, natural gas bills for a small office building located in Burns Lake, BC. It would have been better if I had a building in Virginia, but I didn't have monthly utility bills for any buildings in Virginia, so I've just picked this one. And we can imagine that we've been told by the manager of this building that they've done some energy efficiency measures at some point in time, and they'd like to know, they're not telling us when they did them, they can't remember, or they lost track, or they're not sure, but they'd like to know, how much energy savings those measures led to. So all they're going to give us is an Excel file with these kind of monthly utility bills. And I put monthly in quotation marks here because, as you'll see, they're not actually monthly. The period varies. So sometimes it's 25 days, sometimes it's 35 days. And what we've been asked is, when were these energy efficiency measures implemented? So we're supposed to look at this data and tell the manager when they were implemented and how much savings resulted from them. So let's look at this file. I've got this file right here. So it's just an Excel file. Make that a bit bigger. So here we have the year of the day, the month, and the day. And if it wasn't in this format, it'd be okay. RETScreen can figure out other formats as well. This is a pretty safe format, but you could use other formats. And here's the gas consumption. The gas consumption is in gigajoules. That's what's used in British Columbia. But if this was in millions of BTUs or thousands of cubic feet or therms or whatever unit you prefer, that would be okay. Everything else will work exactly the same way. You just choose different units when you're using the software. But here's the data we have, and I'll just scroll down. We see it starts in 2005 and goes to 2011, and there's a lot of numbers there. Just looking at those numbers, it seems like over time they're getting smaller. So the natural gas consumption is going down, so that's good. But it's not totally obvious when these measures were implemented, when they did these energy efficiency measures. I can't just pick that out. And I can't really just look at this and tell how much energy savings were achieved by those measures. It's not a trivial task that we've been given. And there are two reasons it's not trivial. The first I'd like to point out is that the period length is changing from one bill to the next. So it's not always on the same day. It's not always like a 30-day period, a 31-day period that the billing is done on. Sometimes the period's longer, sometimes it's shorter. So when I see this number, this gas consumption number going up or down, I have to think about whether that's because the building's consuming more energy or less energy, or is it simply because this period is longer or shorter? So that's one thing that's complicating my life. The other thing that's complicating my life is the weather's changing, right? If I compare January and February of 2006, I see that there's less gas being consumed in February. Is that because something's being done more efficiently in February, or is it because February was just simply a warmer month than January? So that's another thing that makes my life complicated. And I would like to have my RETScreen software eliminate these two spurious sources of variation so I can see that from month to month, is my gas consumption really changing? Is my system really performing differently? So let's see very quickly how that software, this software can help us with that. So I'm going to close up this Excel file so that I can actually load it into the software. And I go to the software, and now I'm not going to be doing a feasibility analysis. I'm going to be doing a performance analysis. I'm going to click performance here. I'm not going to save my changes. And first up, I have to specify the location. So I'm going to click here to specify in the same way that I did before that this is in Burns Lake, BC. And it finds that there. Actually, I'll click that one. And it finds Burns Lake. So just in case if you're wondering where we're talking, it's in the central part of the westernmost province of Canada. So if I zoom out, you see there my two, oops, zoomed in a little bit too much. You can see there it is, Western North America, right in the center of this mountainous area here. It's a fairly cool, cold climate, so they need to use natural gas to heat the building, and that's what we're investigating, whether their energy efficiency measures have resulted in some savings or not. So I'll zoom back in, and you can see that this is genuinely located at Burns Lake. So once again, here's the climate data. It's NASA data in this case, and here's the location of the project. So I'm going to drop it here. Happy with that. Click OK. It updates this map. Now, it's providing this climate data along the bottom here. We have to be careful. We're not really interested in climate data when we're doing performance analysis. What we're interested in weather data, and that's different. Climate is long-term average weather, but I'm not interested in long-term averages. I'm interested in how daily or monthly changes in the weather are affecting my natural gas consumption. So this is all very nice to look at, but it's not really solving the problem of helping me separate out the influence of weather from the underlying performance of my building in terms of consuming natural gas. So I'm going to have to get some weather data in here, and I'm going to do that in a bit. But what I've done now is simply specify the location where it's going to get the weather data from, and I've also said, the climate data is there for us to look at, but it's not really that helpful. Now I go to the facility page. Here I can specify that this is a commercial institutional building, it's an office building, and it's going to draw up, a different image depending on what I've chosen there. I should go out and enter something useful here, but I'm not going to because I don't have time. It's updated the benchmark for an office building. If I knew this was, say, 500 square meters, I could enter that. Changes to feet, so you don't have to look at square meters all the time. And there's some benchmarks available for this, and a graph that kind of says if my base case is here and I reduce my energy by 15%, then this is going to move down to 23 kilowatt hours per square foot. So it's just a way of expressing this. If I move it down further, eventually I go net zero and even positive energy. But what I'm really interested in is performance analysis. So I click here to data, and the first thing I have to do is get my utility data in here. So step 1, consumption of production data. I've got fuel consumption here. That's exactly what I want, natural gas consumption in gigajoules. So I click here and it opens up a blank table that looks like this. There's no data in here right now, but this is a blank table that allows me to put in fuel consumption in gigajoules. So if I want to get that in, rather than manually entering it row by row, I'm just going to go over here to options and import the data from that file. So if I go, let's see, onto that here, and there is the file I was just looking at. It's the Excel file. I click open on that, and it brings up this header telling me how it thinks it should interpret this. Year, month, and the day is fine. It's got it wrong for this column. It's not the cost. It's actually the fuel consumption, so I'll correct it there. But now I've told it how to interpret what it's found in this file. I click OK, and it populates this table. It's also added a column, which is it's just calculated the duration of each of these periods, and we can verify that, in fact, it is changing from, say, 26 up to 36 days. So that's one of the sources of variation that we want to remove. So there we've got our natural gas consumption. The thing we think is affecting our natural gas consumption is the weather. That's a factor of influence. It's influencing our consumption data. So let's open up a table for weather. So here's a blank table with all sorts of weather parameters that I could fill out. Now, if I had measurements from my site and I put them in a file, I can definitely enter those into this table. I can import a file just like I did and use my on-site measurements to populate this table. If I don't have that, however, I can download NASA satellite data. So there's a near real-time satellite database of daily weather data for all locations across the planet, being provided by NASA. So I'm not going to be too careful about my dates. I know that my period of interest starts in late 2005, so I'm just going to go back to 2001 and ask NASA to provide me with 16 years worth of daily data. It contacts the NASA database, satellite weather database, gets this data, and there were 72 values that were missing, so it's just putting averages for that. But over 17 years of daily data, that's pretty good. If I click OK, I see there's the data for all those different parameters, starting in 2001 and going pretty much up until a few days ago. So that's what I mean by near real time. We can get data that's up until a few days ago and use that in our analysis to keep our analysis up to date. Now, there are a lot of parameters here that I'm not interested in. For instance, I don't think that the wind speed is really affecting me much here. What I think might be affecting is the temperature. However, it's not just the temperature, it's the temperature when it's cold enough for my building to need heating. So let's assume that my building doesn't need heating when the air temperature outside is above 16 degrees Celsius, which I guess is around, what, 60 degrees Fahrenheit, something like that. So I'm going to do a calculation based on these average air temperatures to determine how much the building is below this threshold of 16 degrees. And those of you who work with buildings will recognize that what I'm talking about is a degree days measurement. So I'm going to calculate the heating degree days for a temperature below 16 degrees for this location using this NASA weather database. So I click OK, and it's going to add a column over here where, based on this data here, this temperature data, it's calculated the heating degree days, a reference temperature of 16 degrees. So for this first day, for instance, we had 19 heating degree days because it was -3. The reference temperature is 16, so there's 19 is the difference between plus 16 and -3. So it's done that for every day in this chart. So I can do other types of data processing too, right? Like it's not just the heating degree days. I could also calculate the solar radiation on a tilted surface as opposed to the horizontal surface. What I'm really interested in is getting this natural gas table and this weather table onto the same page. So I've got this natural gas, and it's in these periods that are roughly 1 month long, but not exactly 1 month. And then I've got weather data, which is on a daily basis. So I'd like to get these figures over into this table so I can view everything on a single table. So I'd like to see the heating degree days for each of these periods on this table. And maybe I think also that, say, solar radiation plays a role. So let's get that in here. So to do that, I'm going to do something called merging. So my destination table is the natural gas table. And I want to take from the weather table the heating degree days that I just calculated and drop those in. So I do that, and there's the heating degree days for each of these periods. And maybe just out of interest, I'll also add in the solar radiation on the horizontal. So I'll put that in as well. So there's the solar radiation, the daily solar radiation, the horizontal for each of these periods. So now I've got a single table that for each of these periods tells me what the natural gas consumption is, what the heating degree days are, and what the daily solar radiation is. So this table should help me in terms of interpreting these numbers if I can find some sort of mathematical relationship that describes these two. So to do that, I go to Analytics here, and I try and find an equation by using a regression analysis. So I'm going to... I'm sorry? Okay. So I'm going to do a regression analysis where I'm going to use all the data to find an equation that relates my fuel consumption to my heating degree days. So I click OK here, and you'll see what it's done is this scatter of points here is each line from that table gives a number in terms of fuel consumption, gigajoules per day, as a function of heating degree days per day from that table. And so you see there's a scatter of points, and it's tried to fit a straight line through them. Doesn't work terribly well. There's a lot of scatter in this points, but it's kind of got the trend there. And we can see that if you're familiar with R-squared coefficient of determination, the fit of this line to this scatter data isn't great. It's okay. It's not particularly spectacular. But what it's done is it's found an equation, this line, that kind of fits this data. And then that tells me that if I know the heating degree days, then using this line, I can estimate what the fuel consumption should be. So if I get a measurement and it's the heating degree days per day is 18 heating degree days per day, then I should be using just a bit under 2 gigajoules of natural gas. That's my prediction. And I can compare my prediction with my actual fuel consumption. So the baseline, or the prediction, is the blue line here, and the actual fuel consumption is the green line. So initially I underpredict, and after presumably some energy efficiency measures, I overpredict.
Michael, a question here in the chat box regarding occupancy factor and adjustments. Can you easily adjust for weekends or other similar changes in use of the facility?
Certain changes, yes. Like you can define the season which you're looking at, but often you'll want to leave things like the weekends in there. The reason you'll want to leave the weekends in there is because you're going to have the building operating in two different modes, like once when it's occupied and once when it's not occupied. And the natural gas consumption, for instance, for this building would cover both of those periods. So, yeah, I'm just thinking back to examples or cases where I've worked on where I haven't found it necessary to separate out the weekends. However, there are times when definitely occupancy, as you suggest, is the important factor of influence. So you could generate a table here like an occupancy table, where that would be then your factor of influence here. So you would, for each of the periods in the occupancy table, you would say, you know, how many people are in the building during that period, and then you could bring that over to your natural gas table. So yes, you can do it by putting in an occupancy table here and then merging it with your natural gas table. It's pretty simple, straightforward to do. However, in my experience, it hasn't been necessary to do that.
Great. Thank you, Michael. And we are coming up on the 90th minute of the webinar. We're going to run a bit over, but we're getting towards the end of it, so I appreciate everyone's flexibility here. Another question from the chat box. Regression analysis, is that the only option for estimating a fit between heating degree days and fuel consumption within RETScreen?
So I assume that the question is a linear equation the only option? And the answer is no, not at all. Generally speaking, starting with a linear equation is a smart idea, but if you want to fit some other equation, you have a vast range of choices here. I would suggest that very rarely would you want to use most of these exotic equations, because you're fooling yourself if you think that just because you're using a 10th order polynomial, you're getting a better fit, that you're actually doing a better job of explaining the variation. But if you have reason to believe, for instance, that the natural gas should be a quadratic equation of heating degree days, you could certainly pick that equation. But linear is always a good place to start. So I've got this regression now set up, and I'm going to now do something called a Q-sum, a cumulative sum of differences. And what that does is it looks at the difference between my prediction and my actual fuel consumption. And if my prediction was unbiased, then certain months it'd be a bit high and certain months it'd be a bit low. But overall, if I sum the differences between the prediction and the actual fuel consumption, I'll see that the high months cancel out with the low months, and the running sum of the differences stays around 0. But if I'm consistently over-predicting or under-predicting my actual fuel consumption, then from month to month the difference accumulates. And I see that as a trend in the Q-sum, this cumulative sum. So I'm going to do that now for my all-data regression here. And I see that initially I'm under-predicting the fuel consumption, and then after a while I'm over-predicting. So this change in slope here suggests to me that there's probably been a change in the way the building consumes natural gas right around this date here. So around April 23rd, 2007. So now I'm going to go back and I'm going to say, hey, this is before any energy efficiency measures were implemented. Let's generate an equation that's just based on this data, and then we can see how our system would have performed if I hadn't done these measures, because this equation is going to represent the building before energy efficiency measures were done. So I'm going to generate a new baseline, new regression analysis, and this is before energy efficiency, and I'm going to do that. And instead of picking all the data here, I'm going to just pick first a few months of data. So if I change this to months, and I keep adding months in here, I can see, the R-squared value stays pretty good as I add months. You know, it's staying very high, near 1, which is a perfect fit, until right about there. Right now it's really deteriorated. So if I back this off to, say, 16 months or so, I have a very high R-squared value. I use that. I can see that this line is fitting these points nicely. So I use that as my equation, and then I do the Q-sum again, and that's what I see, right? I can have this equation doing a really great job of predicting or estimating my fuel consumption before I did my energy efficiency measures. But once I do those energy efficiency measures, my prediction says, well, you should be consuming this amount of energy, and in reality, my consumption is going down like this. So if I just position my cursor at the end here, I see that the difference between what I would have consumed if I hadn't done those energy efficiency measures and what I actually consumed is 2,465 gigajoules. So this difference here is the difference between what would have happened if I hadn't made any changes and what actually did happen. So right there, this graph tells me the answer to the two questions we had. When did things occur? Well, we can see it happened around March, April 2007. What impact did it have? It did about 2,500 gigajoules of savings over this period. And I can also look at that on a measurement and verification graph. So starting at this date, this green is the actual fuel consumption, and this blue is what we would have consumed according to that equation we just did if we hadn't made any energy efficiency improvements. So the difference between the two is this 2,465 gigajoules. That's our energy savings as of that date. So that's a really quick introduction to performance analysis. I'm still supposed to get through portfolio analysis. What do you think here, John? Should I keep going?
Maybe just a few main points and show folks where it's at on portfolio analysis.
All right. So portfolio analysis is when you have a collection of buildings. So I've got a built-in sample portfolio in RETScreen. So if I open that up, it shows me that there's a bunch of buildings that I've analyzed in RETScreen, and I've brought them together into a single kind of database, which allows me to select between different buildings and then group them into groups depending on criteria I select, and then look at energy consumption with each of those groups, or energy production. So this is a sample portfolio that's already been built. These are all the different analyses that are in there. You can see that some of them are performance analyses, like we were just looking at. Some are feasibility analyses, and then some are just benchmark analyses. And there's been some groups that have been created, like commercial buildings here, green power buildings, or office or laboratory buildings. I can create a new group for you. For instance, if I click here, new group, let's create a group that's just buildings in USA. So I'm going to select the buildings where the country is the United States of America. So I click OK there, and it generates this group. So these are all my buildings, and if I show all my buildings on a map here, I see that they're scattered across mainly Canada with a few in the United States. But if I close that up and go to my buildings in USA group, and I look at that on the map, I see that there's one here, there's one here, and it actually, if I hover over it, it'll show me what that facility is, and there's one here. Nothing in Virginia yet, but maybe we can add something in. So that's how I generate groups. What I can then do is go over to this dashboard and generate some graphics for different groups. So as an example, I'll just generate one graphic here. I am going to, whoops, that's not what I wanted. I'm going to generate, I'm going to generate a graphic based on performance data. So I'll call this a new graph. Not very instructive. But I'm going to look at fuel consumption in the units of kilowatt hours. And I'm not going to compare it with anything here, but I'm going to do an annual bar graph, a stacked bar graph, looking only at this group, the office or laboratory buildings. So I can see here are the groups that I have, the buildings in the USA, green power, commercial buildings, all buildings, or office or laboratory. I'm going to pick office or laboratory, and I want to compare across the different facilities. So I'll say, you know, show me each of the facilities in there. And rather than looking at all fuels, maybe I would just want to look at, say, electricity. So I want to look at the electricity consumption for each of these buildings, you know, here by calendar year. And I'm going to do it, yeah, over the entire period here. So I click on that, and I have, I believe, a new graph here. Yeah. So here's a new graph. That's what I'm looking at here. It shows me for each of the years for which I have performance data, and this hasn't been updated, so it ends in 2016. There were 4 buildings in that group. So the buildings were named Fredericton, Quebec, Edmonton, and Varennes. And it shows me this is their electricity consumption in kilowatt hours during each of those years. Now, maybe that's not a very interesting graph for you. Also, you can see when I hover over this, I can see what the contents of each bar is, and I can also find that in the table down here. But there's many different ways you can change the format of that graph. So if you're interested in saying, for instance, all fuels, you would change that away from single fuels. If you're interested in grouping them by, say, province or state, you'd do that. And now you're looking at, buildings that are in Alberta, buildings that are in New Brunswick, buildings that are in Quebec. So those are different provinces in Canada. So this allows you to configure what you're seeing in that graph in a wide range of different ways so that you can investigate energy consumption across your portfolio of buildings and pick apart, if there are trends by province, by fuel type, things like that. And it doesn't have to be just fuel consumption. It could be fuel cost. It could be GHG emissions. You can look at all that. So we have some examples already in this sample portfolio, say of greenhouse gas emissions for those same buildings.
That's very helpful. I mean, essentially, the user defines what's in the portfolio, and then they can run, again, user-defined queries to summarize metrics of interest for different things in that portfolio. So I think that's a pretty neat tool. Thank you for showing that.
Thanks, and sorry for running over time.
No, I think that's on my end. I really appreciate the presentation here. I didn't mean to cut you off, Michael. Did you have any concluding comments, or is that a good stopping point?
I think the only thing that I have to conclude with is if you're interested in more information about RETScreen, particularly if you're located near John, you should contact John. If you're not located near John, you could contact me. There's some contact information there. Particularly if you're interested in, for instance, more training or more information about RETScreen.
Great. Thank you very much, Michael. And again, our experiences with the 7 workshops that Michael's led here in Virginia has just been a great trainer, and I think we got a taste of that in the introductory webinar today. Michael, what I'm going to do is take the controls back. I need to take the presenter controls back to be able to initiate the few poll questions I have here.
Yeah.
Okay, great. I've opened the poll questions. Hopefully you see, 6 questions there on your screen. Please take a moment and respond to those. That your feedback helps us improve and make the next session better than the previous. So appreciate your input there. While folks are filling this out, if you could, if you have any final kind of questions, please feel free to put them into the chat box there, and we'll relay them to Michael. But short of that, thank you all very much for your time today. Apologize we ran over a little bit, but I think the information was beneficial, and certainly appreciate Michael Ross for sharing his expertise with us. So thank you all again, and especially Michael, thank you again for your help.
My pleasure, John. Thank you very much for having me, and thanks for all the questions and the interest.
Great, and with that, I'll keep an eye out here in the chat box, but the poll will close in about 3.5 minutes, and that will conclude our webinar.